Hello, this is Instructor Rick Powers from Western Technical College, Basic Statistics. Lesson 27, Confidence Intervals, the mean. Confidence intervals for the mean have the same purpose as confidence intervals for the proportion. We start with sample information and we get an interval which we hope will contain population information. For example, we might have a group of 20 patients that are being treated for migraines, and we measure their average hours of sleep. So we want to know, based on that sample number, what would be the population mean. Let's use technology to do this. Sample size of 20, let's say the sample mean is 6.2 hours, and the sample standard deviation is 1.1 hours. The answer, population mean, mu, is between 5.69 and 6.71 with 95% confidence. There are things to learn from the equations, so here they are. The lower bound, x bar minus t subscript alpha over 2 multiplied by s over the square root of n. Upper bound, x bar plus t of alpha over 2 multiplied by s over the square root of n. They have a similar form to the equations for the proportion, but also some important differences. Note that the form of these equations is like the empirical rule, a center number plus or minus something times a standard deviation. Recall that the standard deviation of the sample means has the square root of the sample size in the denominator. But there's an important change. We do not use the population standard deviation since we most likely don't know it. This really messes up the process because now we have two sample numbers that are uncertain, the sample mean and the sample standard deviation. Since there are two kinds of variation, it turns out we cannot use z-scores to control the width of the interval. There's a famous paper that was written by a man who had to keep his identity secret, so he called himself student. He proposed using a different distribution called the t-score, which includes both kinds of variation in order to make the intervals have the correct size. The nice part about using technology is we don't need to get all complicated about finding the t-score since the software does that all for us. However, the general shape of the t-distribution is good to know, and it really isn't too difficult. The t-score comes from a shape that is very similar to the normal curve. Number one, most of the data is in the middle. Number two, it has tails. And number three, it's the same on both sides. However, the tails become larger as the sample size becomes smaller. Here's a picture of the t-distribution, which changes its shape for different values of n. From this, we make the following observations. Using the t-distribution might not make a lot of difference for large samples. However, since the tails might be really important for certain types of decisions, it is necessary to consider the possible changes involved when using t versus using z. Another note, most textbooks do not use the sample size n when talking about t-scores. They introduce a new idea, degrees of freedom, which is equal to the number n minus 1. For example, if the sample size is 20, then degrees of freedom is equal to 19. Once again, a strange tradition. End of lesson 27.